you doing?
It's all wrong.
That's not the formula Gauss invented. Are you serious? No, stop it. What are you doing?
Oh, guys, we have guests.
Oh.
Didn't see you there.
Hi, I'm Alex,
I'm Christian.
And I'm Jared Duchin.
and today we're going to be teaching you the magic of
Stats 100.
Stats 100.
Yes, sir.
That's right. We'll teach you tutorials to get you through Unit 1, 2, and 3.
A few from each.
Let's get started. The question reads, the 12 apostles all enjoy their fair share of bread and wine. At the Last Supper, they decide to keep tabs on how much they all ate, in pounds, because, you know, it's the Last Supper. These are the results. Calculate a 5-number summary. These 12 numbers all need to be rearranged into order in which they were from smallest to largest. I've already done that to save time, but in calculating a 5-number summary, one of the main challenges is collecting 5 pieces of data. But in reality, these 5 pieces of data are fairly easy to collect, 2 of them being the max and minimum, which are 2.5 for the minimum, and the max being 6. First and last number, see here and here. The other 3 numbers are the medium, the quartile 1, and the quartile 3. I wrote down the formulas for finding quartile 1, quartile 3, and the median. For finding quartile 1, you want a 25% in, which is 0.25 times the number of trials, which is 12, plus 1. So you get 0.25 times 13. And it's similar for quartile 3, except for it's 75%, so 0.75. And the median is directly in the center, 0.5. The reason this can be tricky is that you get the number 3.25 and you think that's the quartile, but you actually have to go to the third number and 0.25 from it. So 1, 2, 3. And 0.25 between 3 and 3 is 3. So it just equals 3. For quartile 3, you got to count to 9.75, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. 0.75 between 5 and 5 is 5. It can get tricky though. It can get tricky if you have a number for the median, let's say, where you only have to go to 6.5. 1, 2, 3, 4, 5, 6. And you have a difference between 4 and 4.75. So you have to go halfway in between those. And to do this, you can simply minus that from that to get the extra bit, which is 0.75, and multiply it by 0.5. So you get that, and you get 0.375, which is then your median number, and you add that to 4, so 4 plus 0.375 equals 4.75. 375, sorry, my bad. Once you have all of these numbers, plus the max and minimum numbers, you can start drawing your diagram, which I'll do. Plot with the minimum number just being 2.5, the max number 6, the quartile 1 being 3, quartile 3 being 5, and the median down the center, which is 4.375. Box plots are useful as they allow a quick visual representation of what the data is all about. And that's why box plots and 5-number summaries are useful.
The following tutorial is the second example of Unit 1. One thing that really confused me in the first unit of Stats 100 was levels of measurement. Basically, there are 4 different terms that data can be measured under. The 4 levels of measurement are nominal data, ordinal data, interval data, and ratio data. To help you understand them, I will explain each one separately. Before you start any question, there are 3 questions that you need to think of in order to help you do the question. The first question is the data rankable? The second question is, does the data have a constant scale? And the third and final question is there a natural zero? If you are able to answer all 3 of these questions, then you'll be able to do this. The first level of measurement is the most basic level, which is nominal data. It is simply the name of something or type of something. When you ask the first question, is the data rankable? If the question is no, you know it is nominal data. But if the answer is yes, you move on to the next question. Some examples would be the name of the school you go to, University of Regina, or the type of cell phone you have, an iPhone. The second level of measurement is ordinal data. This is simply quantities that have natural ordering, such as the order of people finishing a race, or the choice on a rating scale between 1 and 10. If you ask the first question and the data is in fact rankable, you should ask the second question, does the data have a constant scale? If the answer is no, then you know it is ordinal data. And if the answer is yes, you know it is not ordinal data, and you go on to the next question. It's easy to remember the name of this one because the data is ordered, hence ordinal. The third level of measurement is interval data. It is simply when there is no natural zero, such as temperature, where you can measure temperature in Celsius or Fahrenheit, where the weather can be the same, but the number is different. For interval data, you ask yourself the question, is there a natural zero? If there are not any natural zeros, you know that it is interval data. But if there is a natural zero, you know it can't be interval data. In the case that there is a natural zero, you move on to ratio data. The fourth and final level of measurement is ratio data. It is simply when there is a natural zero, such as time or even people in a classroom or even income, because they all have a natural zero. Finally, if you answered yes to the data having a natural zero, then you know it has to be ratio data because there's nothing higher than ratio data. Now, to help you understand, I created 4 examples, and I'll go through each one. The first one is the color of M&Ms in a bag. So you have to ask yourself the 3 questions. The first one being, is the data rankable? And by looking at it, you can see that you really can't rank the colors of M&Ms, so you know that it's nominal. The second example is the temperature in a room. So you ask yourself the 3 questions. First off, is the data rankable? And you know it is because you can tell that temperature is ranked. Then you go on to, does the data have a constant scale? And in fact, temperature does have a constant scale. And then you go on to see, is there a natural zero? And you know that there isn't with temperature. There's no natural zero because you can look at Celsius and Fahrenheit and it's the same temperature, but it's different numbers. So the answer is interval data. The third example is the ethnicity of people in your class. First off, you want to go and ask the question, is the data rankable? And right off the bat, you know that the data is not rankable, so it's obviously nominal. The fourth and final example is the income of a specific doctor. So you want to go ahead and ask the 3 questions as usual. Is the data rankable? And you do know that the income of a doctor is in fact rankable. Then you go on to the next question, does the data have a constant scale? And yes, income does have a constant scale. And then you finally go on to, is there a natural zero? And the answer is yes, there can be a natural zero. A doctor could hypothetically make no money. And that means it's ratio.
Okay, and I'll be starting Unit 2 with discrete probability. With discrete probability, there's binomial discrete, Poisson discrete, and hypogeometric discrete. I'll be talking about the hypogeometric discrete. The reason that I chose hypogeometric is that's the one that I found the toughest. Now when you look at a question and you try to figure out if it's discrete or continuous, you just look at the question. If there's a finite number of values, that means it's discrete. If there's physical measurement, many values, length, weight, or height, that means it's continuous. Now when you find out it's discrete, you have to choose if it's either binomial, Poisson, or hypogeometric. Hypogeometric meaning there's only 2 possible outcomes, sample must be random, and solutions are not replaceable. The formula, it looks confusing. It's Px equals 0, Cmk, Cn minus m, n minus k, divided by C big N over little n. Now, you just have to break it down. The big N is the total number of items in the problem. The little n is the number of items in the sample selected. And K equals the number of sample size. And also there's M, which equals the random variable. So now we're going to look at a question. Okay, so the question reads, consider 5 balls are chosen randomly from the total of 10 balls without repetition. Calculate the probability of getting exactly 2 red balls out of 6 red balls. Okay, looking at this question, you know it's going to be discrete because there are only finite numbers in here. So 5, 10, 6, 2. And now, what kind of discrete is it? You have to look at it. There's only 2 possible outcomes, 2. Sample must be random, it's random. And selections are not replaceable, and there's no replacing. So looking at this question, you know it's hypogeometric. Now you just have to break it down. You have to find each letter. N. N equals the total number of items. There are 10 total items. So 10 balls. Write that down. Now little n. To find little n, it says number of items in the sample size. 6. Because it says out of 6. Now m equals 5 because it says consider 5 balls are being randomly chosen. And if you look, m is the number of items in the sample selected. And the last letter we have to find is k. And by finding k, number of items in the random variable. So 2. 2 red balls out of 6. So there you have all the letters, and it's simply a matter of plugging it in. Okay, so this is going to be what it looks like when you plug everything in. It's going to be C, 5, 2, C, 10 minus 5, 6 minus 2, over 10, 4. Now this is the easy part. All you have to do right here is write it out again. C, 5, 2. Write that out. Do the simple subtraction. 10 minus 5, 5. 6 minus 2, 2. Write it out. Now here comes the tricky part. Now if you look at it, when you place it out, it's going to go 5 divided by 2 minus, oh, can't forget that, 5 minus 2. Now all you have to do at this point is break it down. Okay, so 5, it equals 120. Divided by 2. If you use your calculator, it's going to come up to 2. Now you have to remember that just because you know what this equals doesn't mean you just write it down. Use your calculator. Now when you multiply it, this is what your answer should come out to. And all you simply have to do is divide 120 by 12 and 120 by 24, which should give you 10 and 5 divided by 210. Now what you have to do is multiply 10 by 5, which gives you 50, divided by 210, and your outcome should be, if you did it right, 0.238. And that's how you do a hypogeometric question right there. Before we get into the next part of Unit 2, the contingency table, I have a little joke for everyone. Ready? What did Batman play on his Little League team? That's right, the Bat Boy. Boom.